Okay, class, I'm making this video for you so that you can get a little bit of help with the review and preview. I've selected some problems that I think you're going to need the most help with, and we're going to go ahead and get right to work on them. So the first one we're going to look at is on the front page, problem 2-95. We are going to look at A, E, and D together. So let's start with 2-95A. Okay, on 2-95A, we haven't spent a lot of time looking at this function, and that's why I wanted to do this one together. I'm going to tell you the parent function to this one is y equals 1 over x. Now, the interesting thing about all these functions is that a, h, and k all work about the same way for each of these functions. If you put something in front of the function, that's your a value. It's going to stretch it, compress it, and or flip it. If you put something grouped together with the x value, it's going to move it left or right. And if you put something after the function with the x value, it's going to move it up or down. So with this one, what we're going to do is group together with x our move. If you look at this dotted line down the middle, what that's telling us is that 1 over x has been moved 2 places to the right. So we're going to write our new function as y equals 1 over parentheses x. Remember, it's minus h. Well, since it's -2, we're going to negative makes it +2. And then finally, we always want to check our work. So we're going to put our calculator here. And we are going to graph this. And oh boy, big glare. Okay. See if that graph looks anything like this graph here. Clear out any old stuff. Go up here and do alpha y equals to get our fraction. And we're going to do 1 on top and on bottom parentheses x plus 2. When we go to hit the graph, we're going to compare our two graphs. And it does seem that I have the same shape graph as I do here. And it has been shifted to the left. So I feel pretty confident I've done a good job with that one. All right, let's look at problem D. Let's slide that on up. Problem D is an exponential, and we're going to look at those here in the next few units. But for now, that exponential graph, we have basically looked at it briefly before, and it's y equals some base b to the power x. We're going to go ahead and use the base 2 for now. And I noticed that it's been shifted. Normally it comes along and hugs the x-axis, but it's been shifted down 1, 2, 3 spaces. So we need to bring it down. So we're going to say y equals 2 to the power x, but then to bring it down, we're going to subtract 3. Remember, that's our h that comes after the x value. And then we're going to check our graph on the calculator, make sure that works. Let's see what's going on with this. Okay. Clear out the old graph and let's try a new graph. I am going to zoom. Oh, nope, it looks pretty well there. Oh, okay. We're going to do 2 to the power x minus 3. When we look at our graph, we notice that we do get a fairly similar looking graph to this one. The stretch might be slightly different, but that might be because of just the way the calculator stretches the graph. And it does seem to be shifted down, so we've done a good job on that one. Finally, on E. E's a straight line. So this one's actually a little bit of review from back in Algebra 1. And remember, slope-intercept form is how we write the equation for a graph. So first I'm going to find the intercept here. It's down 1, 2, 3, 4, 5, 6. So our intercept, or m, is -6. And then to get slope, we go between any two whole number points. So I've got this point here, and I see another place where it crosses right on a lattice point, right at a whole number. So I'm going to do my rise over run to see what I do to get there. So actually if I start here, I rise 1, 2, 3 spaces, and I run to the right 1. So 3 over 1 gives me my, I labeled that wrong. That should be my B, which is my intercept. My M is my slope, and it is 3 over 1, or just plain 3. So if I use the equation y equals mx plus b, I get y equals 3x, and my b is minus 6. All right, and that's just a little review from back in algebra. All right, so that's all I'm going to do on 2-95. The rest of them we've done lots of practice with, so I think you should be able to accomplish those. We're going to look at 2-100 for a couple minutes. So I'm sliding on down to 2-100 here. All right, and that's talking about sequences. And while we haven't done sequences in our class, it was a good idea to review some of those because you did them back in Algebra 1. And so for each one of these sequences, you need to figure out how it's moving forward, whether it's multiplying, adding, subtracting, dividing. And then we write a formula based on that. Well, if I look at this one, it's going down definitely. So it's either dividing or subtracting. 20 minus 6 would give me 14. I can't divide by a whole number to get 14. And while that's not necessary, let's just try the minus 6 again and see if that works. So 14 minus 6 does give me 8. So my rule is to subtract 6. So we're going to write an equation, and here is how we wrote that equation. We wrote it as, you could write it as either something called T of n to show that it's a sequence, or you can write it as y equals. I'm going to write it as T of n. It's just like f of x, but we put an n there to show that we're using whole numbers only as our inputs. No half numbers or decimals as inputs. That could be outputs, but not inputs. So T of n equals, then we start with our first term. Well, our first term is 20. And then we're going to say to subtract 6. Well, how many times do we subtract 6? Well, just depends on what term you're looking for. If we call this term 1, we haven't subtracted 6 yet though, right? So here's what we do. We say n minus 1. That minus 1 tells me I started with term 1. If I started with term 2 or term 3, I'd put minus 2 or minus 3 there. If I start with term 0, n minus 0 is obviously just n. So this would be like x equals 1 in your table, all right? Okay, let's look at the next one. The next one, if I take negative 6 and I subtract, what would it be, 18? I get 24, but 24 minus 18 does not give me 96, or negative 96. So I'm thinking maybe I'm multiplying, not adding. So 6 times what would give me 24? 4, right? So negative 6 times 4 gives me negative 24. And if I check it out, negative 24 times 4 gives me negative 96. So this is a slightly different function because I'm multiplying rather than adding or subtracting. I'm still going to write it as T of n equals because we use that when we do sequences, again, to show whole number inputs. And we still start with our starting number, negative 6. But now instead of adding or subtracting, we multiply. So times 4. And then when you multiply over and over again, you don't get that by adding. You get that with an exponent. 4 times 4 times 4 times 4 times 4 would be 4 to the 5th power. So to show that we multiply over and over again, instead of putting n minus 1 down here, we put it up in the exponent. So 4 to the power n minus 1. Needs to be smaller and up high to show it's in the exponent. All right, that's a quick review of sequences. One more that I would like to look at with you guys, and if you need to see this longer, just pause the video. But I'm going to flip over. And the last one I wanted to look at was 2-146. And I'm going to need an extra piece of paper for this one because it may need a little extra work. So I'm going to make sure I'm centered up here. 2-146 is talking about a parabola. It has a vertex at 3, 5 and contains the point 0, 0. And it says find its equation if it's a function. So if it's a function, I'm going to have to come down here and get some space to write. Let's draw a real rough sketch of what that would look like. It would look like a point over 3 up 5. and then a point at 0, 0. And so the only way I can imagine something, oh, it even has the vertex there, so I would have to draw it coming down like that. So if I want to write the equation, y equals a, x minus h, quantity squared plus k, just like we've been using in class all this time. This is a lot like the rabbit problem. This would be 3, 5. This would be 0, 0, and that's really all we need to know to fill this in. So I'm going to start with my hk, which is the 3, 5. Y equals a, x minus 3 squared plus 5. Again, if I go fast, pause it, write it down, and then go back to listening to me. Next step, you guys have this in your notes, is to fill in any point. Well, the point we know is 0, 0, so we're going to fill that in for x and y. So y is going to become 0. X is going to become 0. Then we simply solve for a. So I'm going to take 0 minus 3 squared. You can use your calculator if you need to. That's 9. So I'm going to have now 9a plus 5. I'm going to subtract 5 from both sides, or flip 5 to the other side. So I get minus 5 equals 9a. And then finally, to get the final answer, divide both sides by 9. So negative 5 over a is, or 5 over 9 is my value for a. So I'm going to come back up to the line where I had h and k in my equation. Rewrite that one with this as a. Negative 5 over 9, x minus 3 quantity squared plus 5. And that is my final answer there. Now the last part of this problem asks, well, what if it's not a function? Remember, we talked about those sleeping parabolas in class. So this might be the most challenging, and I wouldn't ask you to do this on a test, but let's talk about a sleeping parabola, right? If it's not a function, let's draw a new sketch of that. What would it look like? Well, let's see. We would have a point at 3, 5, a point at 0, 0, and this being our vertex, the only way I can imagine that working is if it came up to the vertex and turned around and went back this way. Now, we never really talked about equations for sleeping parabolas beyond switching x and y. But that's actually what we'd have to do. Instead of starting with that y equals, we'll start with x equals. We still have an a value. But instead of having x minus h, we're going to have y minus k here. And then we're going to put the plus h at the end. It could work exactly the same way. Fill in hk. Hk is still 3, 5. It's just a little backwards now because the k stays with y and the h goes at the end. So y minus 5 and then plus 3 at the end. Still fill in an xy value, which what we know is 0, 0. Then we'd have to solve, right? 0 minus 5 squared is 25. It's a two-step equation at this point. Flip the 3 to the other side. Divide both sides by 25. And that gives us negative 3 over 25 as our a value. Coming back up to this line right here, just like before, we'd fill in that a value. So x equals negative 3 over 25, y minus 5 quantity squared plus 3. So I would never test you on this. I just wanted you to see that, hey, it still works exactly the same way. We just have to switch x and y because we talked about the whole idea of we have the sleeping parabola, x and y are switched. That is all I'm going to do for you guys on the review preview. The rest is on you. You can always use the homework help or the CPM website to help you out with the ones that I did not work with you. Gonna sign off on this video and make a new video for you to help you with today's lesson.